Hey guys. All right, so a couple of review things. I took the stuff that was mentioned on the quiz and what people told me they wanted to review, so I've got a list behind me. I'm going to start working my way through the list, reviewing these concepts and these ideas. I may break this up into a couple different videos depending on how long it gets, but here we go. So the first thing that I was asked to review was complementary and supplementary. So remember that complementary angles sum to 90 degrees. Supplementary sum to 180 degrees. Okay, so for example, if I have something like 32 degrees and we're asked to find the complement and the supplement, okay, the complement is what I would add to 32 to get to 90. So how do I find that? Well, I find that by doing 90 minus 32. 90 minus 32, let's see, 90 minus 30 is 60. So this would be 58. So the complement of 32 degrees is 58 degrees because 32 plus 58 equals 90. The supplement is something that I add to 32 to get to 180. So to find it, we do 180 minus 32. 180 minus 30 would be 150 minus 2 more, which would be 148. So the supplement of 32 degrees is 148 degrees. Okay, so complement and supplement. Now we can use complement and supplement along with some other ideas like vertical angles, opposite interior angles, etc. to solve things like you saw on the bonus homework. So if I have something like this, I'm going to say that these two lines are parallel, okay? And if I cut those parallel lines with a transversal, so transversal is just a line that cuts through those. Remember that we know some things about these angles. Okay, so for example, these two angles are known as vertical angles. They're equal. These two angles are also equal. Okay, similarly down here, these two are equal and these two are equal. And then we also know that opposite interior angles, these guys are equal. These two are also opposite interior angles. Those are equal. So actually, if I label just one angle on here, I think I can figure out all of the other angles, okay? So I'm gonna label this one, I'm gonna say that looks like, we'll say 50 degrees. Go with me on that journey, okay? So again, I'm gonna make the claim that if I label this one angle, I can figure out all of the other angles in this picture. Let's think about that. Well, first of all, if I just kind of work my way around the circle, here, right, what do I know about this angle and this angle? Well, they are supplementary angles. Why? Because they sit along a flat line, and the flat line has measured 180 degrees. So this angle and this angle are supplementary, which means I can figure out what this angle is by doing 180 minus 50. So this angle must be 130 degrees, okay? Now, if this is 130 degrees, this is also 130 degrees. Okay, that's using vertical angles. Or I could have said that this angle and this angle are also supplementary. Okay, then this has to be 50 degrees as well. Okay, all right. Now, if this is 50, hopping down here, opposite interior angles are equal. So this would also be 50, which would make this 50. Okay, opposite interior angles are equal. This would be 130. I could have also used supplementary to get that, and this would be 130 degrees. Okay, so by labeling one angle in that picture, I'm actually able to figure out all of the rest of the angles in that picture. Okay, so this is two parallel lines cut by a transversal, and we have a bunch of different things there. We have vertical angles, supplementary angles, opposite interior angles. Okay, all kinds of good things. Okay. Let's move on to solving right triangles. So first of all, remember what it means to solve a triangle. When we solve a triangle, it means we want to know the measure of all of the angles, and we also want to know the length of all of the sides. Okay? Now, we've done two types of solving triangles at this point in this class. Both are on the list. We've solved right triangles, and we've also solved oblique triangles. Remember the difference. A right triangle has a right angle, an oblique triangle doesn't. So an oblique triangle is anything that is not a right triangle. The two use different techniques, okay? So let's just kind of talk first about the two techniques we use when we're solving right triangles versus solving oblique triangles, okay? So here is a right triangle. How do I know it's a right triangle? Well, I know it's a right triangle because it has a right angle right here, okay? Now here is an example of an oblique triangle. How do I know it's an oblique triangle? I know it's an oblique triangle because it doesn't have a right angle, okay? So how do we go about solving these things? Well, we use a little bit different techniques, okay? Now, in order to solve either one of these, we have to know something, right? And the big thing to remember is that in order to solve a triangle, you need to know one side length and two other pieces of information, okay? So that could be a side length and two other side lengths. That could be a side length and two angles, or that could be a side length and an angle and another side length. But you need to know a side length and at least two other pieces of information. With that, you can solve the triangle, or sometimes for oblique triangles, figure out that there is no solution. That also counts as solving because you've figured out what's going on with the triangle, okay? So there's a couple of different cases that we can see, right? So for a right triangle, let's just start labeling things and think about how we might solve this. So let's say that I know this side is 3, and I know this angle here is, I don't know, let's say that this angle here is, I hate making up stuff, 40, okay, 40 degrees. Okay, now I'm going to make the claim that here I know a side length and two other pieces of information. I know this side length, I know this angle measure, and I know this angle measure. With those three pieces of information, I can fully solve this triangle. Solving a triangle means figuring out all the angle measures and all of the side lengths, okay? So let's start with the angle measures here. Angle measure, I know I have 90 degrees, 40 degrees. How do I figure out the third angle? Well, remember that the sum of the angles of a triangle always add to 180. So this has to be 50 degrees. 40 plus 50 plus 90 gives me 180, okay? So now I've solved for my angles. I also need to solve for my sides, okay? I know this side is 3, and now that I know my angles, I can use trig relations to find at least one of the other sides, and then I can use another trig relation or Pythagorean theorem to find the last side. Okay, so what do I mean by trig relations? Well, let's label these things. I'm going to call this A, this B, and this C. That means this is side C, this is side A, and this is side B. Okay, so if I want to find, say, side A, well, how could I do that? Well, let's think about what we know. We know B, length B. We know A, and we also know 50 degrees and 40 degrees. So what I'm going to do is I'm going to write a trig relation that relates those things together. So for example, I could say that the tangent of 50 degrees, so tangent of 50, I'm looking at this angle here. Tangent of 50, tangent is opposite over adjacent. So tangent of 50 is going to be 3 over A. Now notice here, the only thing I don't know is A. Can I solve this for A? Sure, if I multiply both sides of this equation by A, that gives me A equals tangent of 50 degrees. Sorry, A times tangent of 50 equals 3. And then dividing both sides by tangent of 50 gives me A equals 3 divided by tangent of 50 degrees. From here, since 50 degrees is not one of my known angle measures, like 45, 60, 30, things like that, I'm going to go ahead and go to my calculator. I'm going to remind myself that this is in degrees, so I'm going to double check that my calculator is also in degrees, which it is. Phew. Okay. And then I'm going to look at 3 divided by tangent of 50. That gives me 2.517. I'm going to pay attention to rounding here. So let's say that we were asked to round to the nearest hundredth. 2.517 is going to round to 2.52. So this tells me that A is equal to 2.52. Now, was this the only way to do this? No. I also could have said that tangent of 40 is equal to A over 3 and solved that way. Okay? Now I know B, I know A, I want to know C. Again, there are multiple ways to figure out C. I could write a trig relationship. I could say, for example, that sine of 50 is equal to 3 over C. Or I could say that cosine of 50 is equal to A over C. I also, at this point, can use the Pythagorean theorem. Pythagorean theorem applies to right triangles, and it says that A squared plus B squared equals C squared. I know A, I know A, I know B. All I'm looking for is C. let's go ahead and use the Pythagorean theorem. Again, you could have used another trig relationship here as well. If I use the Pythagorean theorem, I get 2.52 squared plus 3 squared equals c squared. I'm going to go ahead and go to my calculator. 2.52 squared plus 3 squared equals 15.354. So 15.354 equals c squared. I'm going to take a square root of that. And I get that c equals 3.917 or 3.92. So c equals 3.92, and I use the Pythagorean theorem to get there. Okay, so this is an example of solving a right triangle. When we solve right triangles, we use Pythagorean theorem, and we also use basic trig properties. The fact that tangent is opposite over adjacent, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. With relationships like those, we can solve any right triangle as long as, again, we have one side length and two other pieces of information. Okay. Now, when we solve oblique triangles, okay, we solve the same thing. We need the same information. Okay. We need one side length and two other pieces of information. But solving oblique triangles, because we don't have things like the Pythagorean theorem, because the Pythagorean theorem only works for right triangles, we have to use other things. In particular, when we solve oblique triangles, we're going to need to use our law of sines and our law of cosines. So I'm going to remind us what those are here, and then a little bit later, when we get to this on the list, I'm going to explicitly solve some oblique triangles. Okay? But again, when we solve oblique triangles, we use our law of sines. So our law of sines says that for any triangle A, B, C, so that means side lengths are A, B, C, the following relationships are true. Sine of angle A over side length A is equal to sine of angle B over side length B is equal to sine of angle C over side length C. That's our law of sines. We also have the law of cosines. Okay, the law of cosines comes in three flavors. Each flavor is very similar. Okay, so I'm going to write all three of them right here. Law of cosines, one version, a squared equals b squared plus c squared. When remembering the law of cosines, I like to think, hey, this is almost like the Pythagorean theorem. Law of cosines comes from the Pythagorean theorem. So a squared plus b squared, a squared equals b squared plus c squared minus 2 times bc cosine of angle A. Okay. Next flavor, I can switch basically where the variables are. So here I'm going to have b squared. It's going to be b squared equals a squared plus c squared. Again, this looks a lot like the Pythagorean theorem. Minus 2 times ac cosine of b. Last version, c squared equals a squared plus b squared minus 2ab cosine of c. Okay. So when we're solving law of sines, when we're solving oblique triangles, we're going to need to use the law of sines and the law of cosines to do so. Okay. So again, I'm going to explicitly go over this a little bit later, probably in the next video, so I have a feeling that's going to get a little long. But remember, with our oblique triangles, we still need two pieces of information, one side length and two other pieces of information. So that means that we get things that look like these flavors, right? Side, side, angle, side, angle, side, 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 angle, angle. Those types of things. These are the relationships that we're going to be solving. Okay? All right, so difference between right triangles and oblique triangles. Solving right triangles is a little more straightforward. We just use Pythagorean theorem and our basic trig functions, tangent, sine, and cosine. That should be enough to solve any right triangle, as long as we, again, have one side length and two other pieces of information. Solving oblique triangles, right, we need the same thing, one side length and two other pieces of information. Some weird things can happen, that ambiguous case of sine, but we're going to solve this using law of sines and law of cosines. Okay, and again, I'll do some explicit examples in the next video. All right, so I think we'll stop here for this video, and then I'll make another one.